All right, Pastry. So this is lesson 51. And it's about graphing an equation, but always linear equation. That means that the data will go up in a line. And the first example is the equation is y minus 2x plus 1 equals 0. And I'll show you that's kind of actually it's not too bad. What you want to do is you kind of want to solve this equation for just one variable, so either for y or x. And that means we're going to get y all alone by itself on one side of the equation. So in order to do that, that means I want to get this minus 2x out of here. That means I'm going to add 2x, because negative 2x plus 2x, it goes away to 0. But that means I need to add it on both sides of the equation. So it goes away over here, and I'm left with y plus 1 equals 2x. 0 plus 2x is 2x. And I still want to get y by itself, so I have to get rid of this 1, and it's plus 1, so I'm going to subtract 1 from both sides. Plus 1 and minus 1 is 0, so I'm left with y equals 2x minus 1. So it's the same equation as the beginning, it's just I've gotten y by itself, and that allows me to solve the equation for y. So I'm just going to set some values for 0. You can really choose any values you want. I just chose 0, 2, negative 2, 3, and 3. That means I'm going to, instead of x, I'm going to put these actual values into the equation and see what y equals. So if x is 0, 2 times 0 is 0, that means this is 0 minus 1. So y equals 0 minus 1, or negative 1. Okay. I can also plug 2 into this equation. Instead of x, put 2. So 2 times 2 is 4, minus 1 is 3. So y equals 3. So when x is 2, y is 3. And instead of 2, I'll say negative 2. So y is 2 times negative 2, or negative 4, minus 1 is negative 5. And then I'll plug in 3 for x. Instead of just saying some random x, I'll say that it's equal to 3. So 2 times 3 is 6, minus 1, or 5. So when x is 3, y equals 5. Okay. And then I will plug in negative 3. So 2 times negative 3 is negative 6, minus 1. So y equals negative 7. Okay. And now I'm going to graph those. And remember, on this is our y-axis is the vertical axis, our x-axis is the horizontal. And our points here are always x first and then y. So 0, negative 1. So on the x-axis, 0. On the y-axis, negative 1. So that's our first point. The next point is 2, 3. So over positive 2, up positive 3. And then negative 2, negative 5. Negative 2, negative 1, 2, 3, 4, 5. 3 and 5, so plus 3 and plus 5. And then negative 3 and negative 7. Negative 3 and negative 1, 2, 3, 4, 5, 6, 7. And as you can see, those make a line. It's a nice straight line. And all these things you're going to do in this lesson is linear. So the equation y minus 2x plus 1 equals 0. We rearranged it for y equal 2x minus 1. Graphically, if you graph out some points, that's what this equation looks like. It forms a line. For any value of y, you can find the x. So like right here, this point would be 1, positive 1. That's a possible answer. Okay, any little point on that line is an answer to this equation. So here, to another example. Make make sure this actually fits on the screen. Okay, and we're going to graph y equals negative x. Okay, and again, I just chose some values, 0, 3, and negative 3. Okay, so if x is 0, then y equals negative 0 or just 0. If x is 3, so if I put a 3 in here, that means y is negative 3. And if x is negative 3, then negative of negative 3 is positive 3. And then we'll graph these points, 0, 0, 3, negative 3, so positive 3, negative 3, and negative 3, positive 3. So negative 3 on the x, positive 3 on the y, and then you just go ahead and connect those dots into a line, and the line goes on forever, okay? And this is how you plot an equation on a graph. You pick some random values, you make sure the equation is solved for y, you pick some random values for x, and you simply solve it. Okay, so this is the equation this is the graph of the equation y equals negative x. Let me do a few more examples for you here. Move that over. Okay. All right, we're going to graph x equal negative 2. So that would mean, since there's no y here, that means y equals whatever it equals. But if you were to choose any value for y, we know that x is always negative 2. So on the x, whatever the value of y is, x is always negative 2. Even if y is negative 1, well, x is negative 2. If y is negative 1, 2, 3, 4, 5, 6, 7, 8, I know that x is negative 2. If y is positive 5, I know x is negative 2. X is always negative 2. So this is the equation for x equal negative 2. You can do where you say x here, y here, and you have a bunch of values for y, like 0, 1, 2, negative 5. But x is always negative 2. And I can graph y equals 2. Okay, remember y is the vertical. So for whatever value of x, y is always positive 2. Always. No matter what x's value is. You know, you've got all these points. Whatever x's value is, y is always 2. So this is y equal 2. And then, one more example, y equal 2x. So whatever x's value is, y is always twice as much. So if x is 0, then 2 times 0 makes y 0. If x is negative 2, okay, so 2 times negative 2 is negative 4. If x is just 2, then 2 times 2 is positive 4. And if x is 4, then 2 times 4 is 8. So we can go ahead and graph these. Y is always 2 times x, so 0, 0. Negative 2, negative 4, negative 2, 1, 2, 3, 4. Oops. Our blue is not graphing right now. Not working. So right there and right there. And 2, 4, 2, 4, and 4, 8. 4, and then up. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So hopefully this is going along fine for you, but we have some equations here, and we're just plugging in some values to see what the equation would look like on a graph. Okay? And of course I have some homework for you in lesson 51. For the practice, do A, B, C, and D. The problem sets 2, 3, 4, 7, and 13, 14, 15, 18, 22, 23, 25, and 27. And so if you run into a problem, email me here at school, and while I'm working with my kids, I'll check my email, or you can text me, and then I'll call you back, or I'll make a little video to run you through whatever particular problem you're struggling with. Love you, pastry. Bye.